In the previous video, we learned about the surprising research of scientists named tiny metallic snowflakes. In this video, we will take a look at the historic nuclear fusion breakthrough. So, let's get started it. On Tuesday, December 13, 2022, US researchers announced a historic nuclear fusion breakthrough, hailing it as a landmark achievement in the quest of an unlimited source of clean power and an end to reliance on fossil fuels. The Lawrence Livermore National Laboratory (LLNL) announced that it has used the world's largest laser for the first time to create a fusion reaction that replicated the process that powers the sun and generated more energy than it took to produce, a goal that scientists have been pursuing for decades. Nuclear fusion has been promoted by proponents as a clean, abundant, and a safe source of energy that could one day free humanity from its reliance on coal, crude oil, natural gas, and other hydrocarbons that are causing a global climate crisis. The achievement of fusion ignition was described by the US Department of Energy as a major scientific breakthrough that will lead to advances in national defense and the future of clean power. However, there is a still long way to go before fusion can be used to power homes and businesses on a large scale. There are significant obstacles not only in science but also in technology. A few decades of research on the underlying technologies could lead to construction of power plant, according to Kim Budil, the director of LLNL. More progress is required. The LLNL, based in California, announced that a team at its National Ignition Facility had achieved net energy gain in an experiment, producing more energy from fusion than the laser energy used to drive it. They fired a bunch of lasers at a pellet of fuel, and more energy was released from the fusion ignition than the lasers, White House science advisor Aarti Prabhakar explained. LLNL researchers used 192 ultra-power lasers to deliver 2.05 megajoules of energy to a tiny capsule smaller than a pea containing hydrogen isotopes for the experiment. It generated 3.15 megajoules of fusion energy. While there was a net energy gain, the laser required 300 megajoules of energy from the electrical grid. Our calculation indicated that a laser system at a scale could produce hundreds of megajoules of energy, so there is a path to target that produce energy in a field, but we are still a long way from there. Mrs. Budil claims that. Fusion, on the other hand, combines two light hydrogen atoms to form one heavier helium atom while releasing a significant amount of energy. That is the process that takes place within stars, including our sun. Fusion reactions can be induced on Earth by heating hydrogen to extreme temperature inside specialized devices. Fusion, like fission, produces no carbon during operations but has many advantages, including no risk of nuclear disaster and much less radioactive waste. Other nuclear fusion projects are being developed all over the world, including the major international project known as ITER, which is currently being built in France. ITER will use magnetic confinements instead of lasers, containing a swirling mass of fusing hydrogen plasma within a massive donut-shaped chamber. Questions: who announced that it has used the world's largest laser for the first time to create a fusion reaction? Which source of energy has been promoted by proponents as a clean, abundant, and safe source of energy? How many lasers were used by researchers to deliver 2.05 megajoules of energy to a tiny capsule? How much energy was generated in the experiment? Which process combines two light hydrogen atoms to form one heavier helium atom while releasing a significant amount of energy? Which other nuclear fusion projects are being developed all over the world? I will wait for your answers in the comment box. Thank you so much for watching and supporting my efforts. Good luck and stay safe.